It's my honor to introduce Rob Zokolov to you. He's our keynote speaker this morning. Rob Zokolov graduated in physics from Harvard University and also did his PhD in theoretical physics from Harvard. Other stations then were Berkeley, Yale, Princeton, Cambridge, Princeton. So I think the last 50 years were Princeton. And the major story of Rob Zokolov is that he's a founding father of the modern environmental discipline. So this is why Rob is here, and this is what he will present in one specific case, because if you talk about environmental science, you can talk about many, many different things, and you can't, of course, do that in half an hour. So Rob will focus on one. Let me highlight, instead of giving all the details of his life that I actually don't know, let me highlight three key accomplishments that are really helpful for the environmental and climate discipline by Rob. And I go backwards in time, so I start with the most recent one, and so it's my totally subjective choice of what I point to here. In 2008-2009, Rob Zokolov spearheaded an assessment of direct air capture for the American Physical Society. And it was a key turning point because it's one of the central technologies that may or may not be important in terms of negative emissions to save us in the second half of the century. There is no silver bullet technology, but if there is one, it may be direct air capture. So that's what was a key assessment, and by this he founded the modern assessment of direct air capture, which is a really important technology study. Another very central point was a key paper together with Steve Pacala in, I think it was 2002, 2004, the wedge paper in Science. It's the idea here is that with using central technologies and options, you can reduce emissions wedge by wedge. And it's, of course, not highly complicated modeling, but it's a highly important communication device of pointing to the key option that you have and their aggregate potential. And it had a huge influence on actually the communication of these climate solutions. And the third one was Rob's starting point, turning from theoretical physics to environmental science. And there were two starting points. Rob will present the second one. I want to point to the first one, which is the environmental assessment of a specific place from very many different disciplines. It's the dam, investigation of a dam construction from the perspective of tourism, from ecology studies, from engineering studies, and from for example, oyster farmers and others that were impacted and had an opinion on that. And the question on what kind of metrics you use when you evaluate that and what can you do wrong in these kind of circumstances, because of course you first have to understand what you can do wrong before you can do it right. Rob, it's a great pleasure to have you here. I'm very pleased and we are looking forward to hear your presentation.
I think that's the best introduction I have ever had. This guy really gets me, and I think I get him. Felix is doing something extraordinary with this new center and with his career. He too has been drawn to the fundamental science questions in neuroscience and in basic physics. And he's got this vision now that I want to support any way I can, that the very deepest thinkers can begin to scope this incredible challenge called sustainability, which I sometimes call bursting the seams. It's an image from a tailor, a Schneider. You gained a little bit of weight. You don't fit in your pants anymore. You go to the cleaners and the tailor, and he fixes it so you fit again. We don't fit on the planet, given what we want to do here, and that's an extraordinary challenge that will be with us. Not for 8 years, because then we cross some threshold, but for much, much longer. But when I found out that this current emphasis will be on cities, which I think is an important choice, I said, well, you know, I actually have some sense of déjà vu. When I was picking a research areas 50 years ago with the assignment of what's important to do that hasn't been done that is intrinsically multidisciplinary, I picked two areas. One, as Felix said, was a decision to build a dam. It was a group activity. I was one of the leaders, but I wasn't the only one. Where the dam was not built, actually, and had a lot of momentum ahead of time. And it was because there were new values, there were environmental values that were against the dam. Whereas in the US story, as you may know, President Roosevelt built a lot of dams in the 1930s, something called TVA, the Tennessee Valley Authority. We were welcoming dams all over the world as one of the smartest ways of getting low-cost energy from the environment. We still have a great fondness for them in the engineering community. But there was clearly something else at stake, and Felix mentioned the oysters, for example, which depended on irregular flow, which was going to be lost in favor of regular flow. Engineers simplify systems. And the dam, I say, dams like that were almost always built before that year and almost never built after, at least in Three Gorges is a major exception in China because there was a time delay in the intelligentsia in China as to when key ideas had power. But I worked on a project, the other project I did in 1970s with others, when we use the first person singular, but there are always many important collaborators, was to study a small community built within 15 kilometers of Princeton, under construction at that time, called a planned unit development, a PUD. It was a concept that you would not just let housing be developed by individual families, planning roughly a square kilometer of low middle income first homes for young families. You see an aerial view, and then you see the individual units, which were owned by the individual and shared walls, townhouses we call them. And on the right, and we said, let's just find out what's going on there. We don't know what the questions are that relate to energy in buildings. Our question was, why does this? Let me go back a step. At the time, the science community believed our job was to produce energy. Nuclear power was one of the things that physicists were drawn to. There was a solar frontier. There was a frontier around advanced higher temperature coal power plants, and even at Princeton, a fusion program all the way back in 1970s. And some of us, young Turks, 30 years old, physicists and others, why are we using as much energy as we do? And I was literally told, that is not your business. You get the energy made. Others of us will figure out in other fields how it should be used. And we said, that can't be. Energy demand is the consequence of decisions that are technical as well. So from that starting point, the field of energy efficiency as a field really began in that time period. The Lawrence Berkeley Laboratory in the US became one of the leaders right around then. I think I contributed to it. And the strategy was go look at what's going on. This is where I feel such kinship with what you're doing now. Felix has emphasized, we don't know the right questions for a sustainable, livable Berlin. We have to go see what's going on, and we don't even know what, as you said, we don't know what we're doing, we don't know what we could be doing wrong until we look. And then in your field, in this field, no American is surprised that Felix's second slide yesterday was Jane Jacobs and Robert Moses. That conflict over the technocrat straightening the highways, tearing down buildings which were colorful and three-dimensional in favor of what things that look straight and pass score well on other criteria. So we'll look at for a small community. And one of the reasons we chose this was that social scientists were studying the same community with the question on their minds, were the objectives of the planning of the planned unit development actually going to be achieved when people moved in? Would they walk to the grocery store, or would they still drive even though it was a short distance? Questions like that. Would teenagers use a community center? We said, if they're studying that, why can't we study the technical side at the same time? How are they built? Why are they using as much energy as they do? Primarily for space heating, but also for the electricity. And we got to know the world of energy efficiency in buildings. So those pictures quickly, I've got to go much faster. We won't get done. But the top left picture is taken from the basement looking up, and there's a gas furnace, and there's an open rectangular shaft going right through the roof, leaving a free passage for hot air to go into the attic from the basement. And the attic has lots of insulation on the floor, and the model in everybody's head was we have a cold attic because we have this insulation and very little heat leakage. However, this was a bypass, as we called it, and was designed into the building for safety of the fire construction. Could have been done in many other ways, but this is the cheap way to do it. So we discovered that attics were warm, that insulation was ineffective, and that got us started. Then there were installation defects. The top right is a missing piece of insulation in the attic floor, looking up at the attic floor from with an infrared camera. And then there were additional design defects. And then we intervened. Something you're going to ask yourselves is, do you want to have intervention be part of your program rather than just watch? So I love this picture. Couldn't have been taken on most days, but this is a winter morning with frost, not snow, but frost, the water condensing, water vapor condensing, on 2 roofs, but not the middle one of the 3. We had added insulation to the 2 on the sides, but not to the middle, so the attic was warmer in the middle one, and it didn't too warm for the frost to form. So you could, if you were a homeowner who was wanting to be ahead of your time and insulate your attic, you could actually show it off on a frosty morning. But the point, of course, is we were intervening in various ways. And intervention, one of the reasons we like this site is because there were repeated units that were more or less identical. And so when you had control groups, you could do one group and do one thing with one group and leave the other alone. So there's a fundamental choice in your research. I would recommend that you think of ways to do interventions with control groups because they have a lot of power. When you have results, of course, many of them won't work. And then one of our most startling results that got us attention immediately, I went personally, and there was nothing digitized. I copied gas consumption numbers out of a notebook that the person had read who worked for the gas utility, house by house, reading a meter, and figured out what the winter consumption of gas was in various houses. And they were nominally identical, and they had this enormous range, which had to do either to people's consumption choices, what temperatures they set thermostats at, or exactly how the building was construction was made, or details like whether they were interior units or external units, what choices they'd made of windows and so forth, window class types and so forth. So we had obviously an interesting data set. This was not intervention. This was just what was going on at the beginning. And I just worked this out for this talk. At the time, we weren't thinking about carbon. I knew how much energy was used in a house, but it's actually 4 tons of CO2 a year per household at the median value there. That's essentially the winter consumption. And 4 tons of CO2 per year is, maybe some of you, it's a number that means something to you. The world puts 40 billion tons of CO2, or more or less, nearly 40 billion tons of CO2 into the atmosphere every year. And there are 8 billion of us. So you divide, you get 5 tons of CO2 a year as our per capita share of the world's current fossil fuel world. And so 4 is essentially your full quota, but it's for a family. There's more than one member. But I'm inserting this slide, which is from more recent talks, which is 5 tons of CO2 a year, the world average, is easy to acquire, to emit when you have ordinary life, ordinary activities, like driving a car. 30,000 kilometers I know is a lot, so you might not get all the way there with a pretty good vehicle, 5 liters, 100 kilometers. Flying is about the same as 5 liter per 100 kilometer vehicles. The vehicle alone and the building and the plane coach class in full plane. Heating a home is the one I picked up here. And then lights, of course, depend on the electrical system, how much carbon is being emitted by the lights in this room right now depends on the carbon intensity of the electric power, which is probably quite similar in New Jersey and here, about averaging to something close to what natural gas does from a variety of sources. So in terms of lessons learned, we looked at, I have 2 slides, one about the occupants. I did this is all sort of new for me to go back to this world. We got to know the occupants' view of what it was like to live in an engineering system called a home with a thermostat and a furnace and other technical and appliances. There was their world. What do they understand? How do they do it? Comfort obviously is a critical variable in an indoor space. And one of the things that we learned there was a whole community of buildings research in the 70s. Some of it was working with lower income homes, where their discovery was that when you tightened them, there was no energy savings whatsoever because people had been uncomfortably cold, and they traded up in temperature toward comfort, and energy wasn't being saved, at which point you have a moral question, if you like. Is that, in fact, exactly what you would like to have happen, or are you so focused on reducing carbon emissions that you would actually preferentially avoid the homes of the poor? You can get to pretty tricky questions. Privacy and convenience, undermining sharing, one of the 70s ideas, and it's back. There's a sense for me of a second wave in this current period. Share things, share things. People don't like to share things. Share children's playground equipment, slides and climbing things. Put them in a central place. People put them in their backyards, and one at a time. There was share laundries. There's all sorts of issues of that kind in a city. What would promote sharing effectively? What's in the way? And then safety. Of course, can't have that enough, I think, unfortunately, in the way in which people think about cities. And biophilia, it's a phrase introduced by Ed Wilson, the ecologist at Harvard, recently died, that we really want greenery around us. I'm looking at a green tree right out that window right this minute, right there as well. That defines what a city does as well. Exuberance, which is one of my favorite words for the fact that we're in a climate problem because we love to do stuff and we love to have stuff. Coming through Berlin Airport yesterday, realized so many places the planes are going to that are modest distances all over Europe. Everybody flying, busy, 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 all coming back to life. That's who we are. And so the climate problem is really difficult because of who we are. And I'm going to talk more about floor area in a moment. But to me, it's the critical variable we aren't looking at. And then I know you heard from Elko Weber, which is a psychologist, yesterday. One of the most interesting things we learned was that people had mental models of equipment. Thermostat is a good example, which are wrong, and nobody challenges it. So if I have a thermostat and I put it up really high, I'll warm up a house faster than if I warm it to set the thermostat just above to the temperature I actually want. If I want to get it warm faster, I'll put it much higher. That doesn't weigh it. A thermostat's a switch, not a valve. And there are examples of what's called folk science that are out there all over the place. We wouldn't find that without asking questions. And the other group, aside from the occupants, were the buildings professionals, and this is really important. This is the link in my mind between my 2 projects in the period of time. All kinds of building professionals determined what happened at Twin Rivers. And they're all in professions which have norms and decision processes, and one after the other, that they kind of drive how it all ends up. If you want social change, these are the agents of social change, but you have to change professional norms, and that is really difficult and slow, but don't underestimate it. So first of all, we had a natural gas system. It wasn't there. It was a town this was farmland. 5 years before we started studying this. So gas pipelines were being put in as by far the lowest cost solution for providing heating, compared to, for example, to trucks delivering oil, which was the other alternative. Heating oil, individual homes for individual tanks. So they put in this front investment, tremendous sunk costs in the process. The site was near a highway exit of of a major highway, New Jersey Turnpike. And that was why it was placed there, with the assumption that many of these people, particularly one of the household owners, it was more generally would be the guy, would get on a bus in the morning and go to work in New York. This was embedded in the concept of the whole community. The high density was a good thing rather than spreading out. But did that really count? There was regulation that determined how much insulation and what kinds of windows would be there. Turned out the regulation that was most important was about the availability of mortgages with conditions. And the major mortgages were federal government, national government mortgages. And the standards in those mortgages for minimum insulation were in fact creeping upward in the favor of lower energy use, but very slowly, but had a tremendous leverage over what would happen. And again, something you'd have to unpick one step at a time. And then one of my favorites, you saw that shaft in the building, but it was just one carrying heat from the basement to the attic. It was one of several examples where designed into the building were energy wasteful things. And so I would say people asked me earlier this morning, how did the university react? Well, the engineers and scientists thought I was crazy to work on something so non-frontier. There's no differential equations, or almost none. But the architects were quite threatened, not less by us than by a whole movement of young architects to push solar architecture, passive and active solar architecture in the 70s, and actually get things built. And I was called upon to talk to architects and planner groups. Famous one at the University of Pennsylvania, where somebody, Ian McCarg, whom some of you probably know in this room, was one of the founders. And I gave a talk, and somebody put their arm around my shoulder afterwards and said, "Oh, you're a performance guy." What did that mean? It meant that I was not particularly interested in design. I was interested in what it was like to live in those places, or how much energy would actually be used, and where energy would be wasted that had no impact on the people themselves. So the architecture world has this tension between design and performance, which the architects in the room know, and others can think about. We trade off performance in a way that I certainly didn't know about further. And of course, cost is driving lots of things. So I'm going to have to move much faster. Drive energy efficiency investments by measurement and performance standards and prices. What impacts did we have? Looking back on this, what can I say about what we actually did? Well, we created a new multidisciplinary field. And I noticed that in Felix's own descriptions of what he wants to do here, it's create a community. Well, call it recreate a community. Because there wasn't a sense in the 70s of fresh questions, go out and find out what's important. A lot's been forgotten. A lot of the questions are newer. We didn't have carbon on our minds, particularly at the time, for example. The single largest success story in policy, and it's not just US, in energy policy, demand policy, was appliance standards. Much, much less efficient, less energy required to run a refrigerator or washing machine, done with the government and the professional groups, done all over the world. China has gone in that direction, for example. New technologies like the light-emitting diode made lighting a much less important part of the total energy demand, as long as it's installed and used and so forth. And window coatings. Windows are very differently available today than before. And then performance monitoring, which is somewhat still somewhat in place, but no project manager wants his project or her project evaluated. And so the whole idea of keeping score, taking a look at what's been actually going on. And then homeowners getting performance information, that changed. The electric bill gives little bar graphs today which say how much energy is used compared to you a year ago. All of that we actually directly ourselves pioneered. And the professional with an infrared camera, not as widely used as one could. It was in fact actually perhaps more used in the 1980s than today. The house doctor, which some sense of professional standing. Go back, and when a building is built, after that is when you need to look. It's hard to get that to happen. Big buildings, small buildings. So the next slides I have are going to be on energy frontier, but I'm just going to list them because I won't run out of time if I don't. But I consider Documenting the building stock is number one. All my career, I've tried to figure out how well we were understanding energy in buildings at the first level, which is how much building is there? How fast is it being built? What is the building stock of Berlin in square meters? I don't know if anybody knows that. Maybe Berlin is a step ahead.
40 square meter per person, so you just have
Is it 40 meters per person, and that's residential space? And that's worked, that's...
the German average is 50 square meter per person, the Berlin average is 40.
So that suggests quite a bit of measurement that wasn't there before to get to that point. And that's, of course, residential space, and then there's commercial space. Then the next question would be, how well do we know? The bottom line says vintage. How old, how do you separate it by vintage? You may be I'm out of date on how well the building stock is defined today in all over the world. But it's the equivalent of how many miles or kilometers we drive. Well, we do have a pretty good sense of the numbers. The solar power future is fascinating around this particular variable. I know Felix and I talk about this a lot. We're going to have a future based on rooftop solar and wall solar, and maybe very community scale solar in small parks. Or we're going to have great big installations in deserts, mostly. What's the balance going to be between those two? And where do buildings come in? Then there's this picture, I hope stimulates some of you to think about, although Berlin doesn't have many pieces, it doesn't look like this very much. Building development in the developing world does look like this. People moving off of farms to their first homes. This is a China complex. We need to understand, I don't think energy efficiency is an objective that is powerful in the design of these enormous structures that use lots of energy. We haven't, to my mind, as soon as this would show up, I'd know that we had some kind of a victory, that we actually thought about these as energy, as impacts on infrastructure. What is a building, what does a new town like this or a new community like this mean for infrastructure? One of your questions is going to be how much do you look at Berlin and how much do you look at Berlin as other cities around, and particularly perhaps twinning with some developing country city, so that you get to questions like this, which are different and so important because the building stock is new. It's being built right now. I'm going to skip this. I'm going to skip that. I'm going to skip. Kallenborg, some of this whole field of industrial ecology, how do materials flow and how do materials flow efficiently. Kallenborg in Denmark is a poster child for the integration of different industries with each other, where the waste products of one industry are the inputs of another, and there is a district heating component of it for the town, which I hadn't really fully been aware of, but it's been on the slide that I've shown. So Kallenborg is, how many of you have heard of Kallenborg? A few of you have. Okay, so it's a poster child for industrial ecology, which is, as I said, materials flows. I know there are people here in public health. Indoor air quality became quite obviously very important as we got into our study, because the building's tightness was a way to get improved, reduced energy efficiency, reduce the airflow through the house, but at some point you build up some kind of contaminant. On my university campus, the laboratory energy flow dominates everything else on the campus because it's deliberate, and it's true of a hospital too, deliberately very, very large airflows, generally not heat recuperation, in order to keep the place healthy. Much more of that lies ahead. And again, I want to just keep moving so we have time. And this one is one of my favorites. If we're going to have a renewable world, we'll choose not to have the same objectives from the engineering community about what electric power should be all about. Today's objective is, when you turn the light switch on, the light should go on, and no matter what, no matter where, every single minute of a year. And nothing should change. The arrival of wind and solar is an immense challenge for that frame of mind. And this is a story, this picture here is a year of Texas wind, total wind for the whole state, hour by hour, and a horizontal line is at half the average of the year. And the 4 areas that are picked out are the four longest periods when the electric power from wind was below that number for a number of hours in a row. Essentially, 3 of those have 21 day of below that average, and one has 2 days below that average. And then that means you're going to perhaps live slightly differently during a period of low wind or low clouds if it's solar. The 1 week scale of the challenge of intermittency, not the 1 hour or the 1 day scale, but the 1 week scale maybe requires something different. So the clothesline, at least when I was a kid, my mother would wash the clothes on a sunny day, because then we would go outside, and I was the guy at 9 years old who got praise from my mom for putting the clothes on a clothesline, and then they dried out, and we didn't do that on a rainy day. So, and then there's in the towns, you probably have this in Germany too, a really big snowstorm, the schools actually close for a day, rather than having the extra equipment to make sure that we never have a snow day. So this mentality is built into where I think the renewables world is going to take us. And so how does Berlin adapt to the natural variability and change the norms of the electric utility industry, which say, no, we will never give in. There are questions here that I think are going to be really challenging and interesting for a new center. And then I do think we want to keep in mind that we're talking primarily about middle-class life, but there is a story of poverty, and a poverty that is below the poverty of almost all of the poorest people of a country like Germany or the United States. And the number one health impact of the energy system of the world is indoor air creating lung respiratory disease in women, especially women and children in developing countries where they're burning wood and wood or biomass in some other form in unvented spaces. We've been talking about it for 50 years. It was just uncovered very early. The picture is a picture of a woman with a stove. First of all, it's the Energy Outlook, World Energy Outlook data that about roughly a million people a year dying of respiratory disease from indoor air. And then the venting of a stove is a forward march. And then the immense importance of the low-cost photovoltaic panel, bring electricity to remote locations where people now have opportunities they didn't have before, just by this one important critical invention. So 4 final slides. I've said a couple of times already, what is this climate problem all about? It's not a problem of poverty. It doesn't go away when you get richer. It gets harder when you get richer. I think Sheila Jasanoff, a psychologist, a social scientist, who some of you know, talked about problems of modernity as opposed to problems of poverty that are solved by development. And it's about what we choose to produce and consume. And we have this view in the Western world, which seems absolutely compelling everywhere, nearly everywhere, not quite everywhere, but nearly everywhere, that we want to live with lots of exuberance and consumption and acquisition and experience. Much experience as consumption. Many cultures in the history of the world define the good life differently. Certainly the Buddhist view was not the current view. Is it conceivable that some future generations will redefine the good life as a way of dealing with the constraints of the planet, the planetary boundaries? I am about the worst advocate of this change because I, at age 20, wanted to more or less go everywhere in the world and see lots of places, and I've done a pretty good job of it. So that's the first problem, is if you like, how to think about the good life. The second is, for this group, is how to think about good research. That's why Felix asked me to come. I'm supposed to be thinking about good research. It's open-ended. It doesn't start with a discipline's definition of what a good question is. It goes and looks. And it keeps quantification in its place. And one of the things, there's a pecking order in science. At the heart of the more advanced the quantification, the more significant the research. You have to put that away. And above all, keep track of what you're not including when you have a quantitative model of some kind, even though you have appreciate the value of the quantitative model itself. This is where when values conflict comes in. There are value conflicts all over this problem. There is no substitute for field work. I've certainly said that a few times by now. Observation, measurement, and evaluation. I mean, some of you know, the architects in this room know that there's something called LEED certification, L-E-E-D. It's all acquired. A LEED designation is acquired before construction. And there's only been a very limited, not zero, but very limited evaluation of high-scoring LEED buildings after they were built. They all do less well than they were supposed to. And I think there was some correlation that the more they were supposed to be exceptional, the bigger the gap with the later performance. We should know that. I think that was the conversation that led someone to call me a performance guy, actually, because it was one of the people involved with LEED. And then one of my favorite words is conditionality. We are not single objective people, and when we're trying to specifically deal with a low carbon world, we also want something else. In fact, it's not clear to me that very many of the people working on the low carbon world really want the low carbon world more than anything else. So it may be that you're really preoccupied with bringing on new technology like solar and wind and hydrogen, and that's the batteries, and that's what gets you up in the morning. Or you may be preoccupied with income transfers, money transfers from the rich to the poor within a country, or more likely between rich and poor countries. That how much money Germany goes to India is what you get up in the morning to accomplish, and if there's a climate change agenda that can help that, that's why you use the climate change agenda. There can be on the other side, I do not want to see nuclear power as part of the low carbon world. I get up in the morning making sure that nuclear power doesn't get on some list. You've had an argument in EU in the last year about that. So these are the conditionalities which energize lots of the conversation about climate change. We have a conversation now in the US about, as you had here, building solar panels in the US, or we don't want them. That's not where the low carbon people are coming from, but it's where a lot of people are coming from in the US, build up domestic content. And of course it makes solar come much more slowly. So we have all these conditions and we have to make them visible. And they can be completely defeating if we have too many of them. The biggest one today is that we don't want a world that is low carbon, but as unequal as it is today. I think that's an interesting. If I were asked 5 years ago, and most of the people I know work in this field, if you could lower the carbon footprint of the planet, on the planet, let's say by a full degree Celsius in terms of where we were heading, but the world was exactly as unequal, measured by various Gini coefficients or whatever, at the end of the day, at the end of this process, which say took 20 years or something, would you consider that a victory? And I would say that most of the people would say, of course it is. My God, this is a scourge. Everyone will be somewhat better off. But it's not true today. The social agenda has been grafted into or fused with the environmental agenda in a way that may be destructive to both, because we're loading a single challenge. We're loading two challenges onto the same horse. I think we need to think about that. I'm very discouraged with what happened in the United States in the last 2 years with a Democratic president, Democratic House and Senate, lots of momentum at the beginning to do something about climate change, and in fact, pretty well thwarted because the coalition wasn't broad enough. And it wasn't broad enough because of the demands of all of the members of the coalition for what had to not be there and be there. So, what I'm urging upon you is a program which I call Destiny Studies. The art and science of looking ahead. It actually doesn't exist as a discipline. What or at least, and I think it will be. What is our collective future and how do we think about it? Even for starters, differentiating a collective future over various time periods, not being distracted by the sun burning out someday, but differentiating decades from centuries and then really bearing down on what we care about. as I say there, one of the striking things about the period in which I have lived is how much we learned about our past. When I was a college student, we were just learning about, we had not sorted out the Big Bang from something called continuous creation. That happened in the 60s. We had not sorted out the story of the Earth and seafloor spreading. That also happened in the 1960s. And DNA happened in the major understanding of who we are, but not where we're going. That's wide open stuff still. And then I've been startled by the realization that it isn't taken for granted by everybody that I know. Maybe everybody in this room, but not everybody whom everybody in this room knows, that we want the human species to continue, that we find it imperative, it's a deep moral sense, that the human species continue. Well, why? There are arguments that we get out of the way of the other species whom we intrude upon so much, or just that it doesn't matter. We've had our chance. Fine. There's a utilitarian view that if we all die, but without lots of suffering, and there isn't a generation after the next 3, that's okay. So if we don't believe that, we have to articulate, and much better than we do right now, why. And my own belief is that our lives are part of an immensely important, very long-term, multi-generational project of self-awareness. We may be the only species in the universe who is asking why we are here. We may not be, but as far as we know, we are. And we have an obligation to assure that our descendants not only exist, but thrive for a very long time. So I am still an optimist. We have, in technical terms, a very inefficient energy system and lots of solar and wind power available to bringing in a whole new way of having a low-carbon world. And we have lots of physical capital, but they are not the most important reasons why I'm an optimist. The fourth one is very smart young people. I will define young pretty broadly. I think you're all young in this room. Find carbon and energy problems exciting and moral issues irresistible. I've shown this slide without those last 4 words for a lot of years. I added them for this talk. I'm struck by the energy, what is energizing this effort, by what I know about Felix, his emphasis on the good life, and by the interaction I've had with young people over the last, increasingly, let me say without it starting, increasingly year by year, that moral issues cannot be excluded and separated and talked about at other places, and that you find them irresistible. So thank you for giving me this opportunity to talk with you.